Alright, this is a response to another question I got on TikTok asking me to do D part 1 from question 9 at the 2015 paper. And this question is based on pH, and in particular in this part we're dealing with Ka values, and this is actually quite a difficult question, so it's very good that I was asked to do this. So it says right there at the top, a sodium hydroxide solution was titrated with the solution of ethanoic acid using the apparatus shown on the right. I've cropped it out there, but anyway, a number of pH readings together with the corresponding volumes of sodium hydroxide solution added are shown in the table there. Okay, so we're looking at D part 1, right? Calculate the initial concentration of ethanoic acid in the beaker. Okay, now I'm going to show you two different ways of doing this. Okay, so for the first one, right, for method 1, we're going to use this formula. pH is equal to minus log to the base 10, right, not concentration of H plus, right, the square root of the Ka times the molarity of the acid. Okay, so here's what we're going to do, right? So the pH, do we have the pH? We actually do, right? Because now you mightn't think it just from looking at the table, but these pH values are actually of the ethanoic acid, not the sodium hydroxide, because it's the pH of the solution. So initially there's no base, so the pH is quite low, as you'd expect, and as the base is added, the pH increases. So the pH, the initial pH of ethanoic acid is 3.3. Okay, so 3.3 is equal to minus log to the base 10 square root. The Ka, which we have, is 1.8 by 10 to the minus 5 times the molarity, which is what we're looking for. Now from here, it's kind of just algebra, depending on how good or bad it is, right? So first thing we want to do is get rid of this minus log to the base 10, or the log to the base 10. And the opposite of minus log to the base 10 is 10 to the power of minus whatever, right? So we have to do that to both sides. So that'll be 10 to the power of minus 3, or yeah, minus 3.3. Okay, and then it would be like 10 to the power of minus log to the base 10 of all this, and these would basically cancel out. So we're left with 10 to the power of minus 3.3 is equal to the square root of 1.8 by 10 to the minus 5 times m. So 10 to the power of minus 3.3 is 5.012 by 10 to the minus 4 is equal to the square root of 1.8 by 10 to the minus 5 times m. Now we want to get rid of the square root, so we'll square both sides. Okay, the square and the square root cancel, so this gives us 1.8 by 10 to the minus 5 times m, and then 5.012 by 10 to the minus 4 squared is 2.512 by 10 to the minus 7. And then to get m, we'll divide both sides by 1.8 by 10 to the minus 5. These will cancel. And then on the other side, we get 2.512 by 10 to the minus 7 over 1.8 by 10 to the minus 5. and we get that the molarity is equal to 0.014 molar. Okay, so that's the first way of doing it. Now, see, depending on how good your algebra is, that may or may not either seem really easy or really tricky, right? Hardest part is probably knowing this line here, right? That minus log to the base 10, to get rid of that on both sides, you're doing 10 to the power of minus whatever, okay? But other than that, yeah, like the method itself is quite straightforward. It's always just making sure you don't go wrong in any of those places, right? But there is another method, and that I will show you anyway. And to do this, you're going to write a dissociation equation, right? So we're dealing with ethanoic acid, right? CH3COOH. And that dissociates into ions, right? So that is going to be CH3COO minus plus H plus, right? That's how it dissociates. And what we can then do, right, is we can write a Ka equation. Now Ka is written the same as an equilibrium constant. It's reactant, or it's products over reactants. So it'll be the concentration of CH3COO minus times the concentration of H plus is equal to, the concentration of CH3COOH. And that there on the bottom is what we're looking for. Okay? Now, first things first, right? Because, right, this ratio here, right, between these two ions here, it's a 1:1 ratio. So we can rewrite this top line as H plus squared over CH3COOH. Now, why did I choose H plus and not the other ion? Well, because we can now get the H plus concentration. Okay, I'll do that first, right? So we know, right, H plus is 10 to the minus pH. That's asked nearly every year, or you're asked to use that formula somehow every year. And our pH is going to be the same as before, the initial, the minus 3.3. And that was 5.012 by 10 to the minus 4, okay? So that's our H plus concentration, and we know our Ka value, because we're told it in the question. It's 1.8 by 10 to the minus 5. So now we have 1.8 by 10 to the minus 5 is equal to 5.012 by 10 to the minus 4 over the concentration of ethanoic acid. Okay, so what we'll do then is I'll just say the algebra. We're going to bring this up here and bring this down here. So we get then the concentration of ethanoic acid is equal to the very same fraction we had earlier, 5.012 by 10 to the minus 4 over 1.8 by 10 to the minus 5. Just to make sure I get the same answer. 5.012 by 10 to the minus 4 over 1.8. Oh, sorry, I forgot to square it. Oops. Sorry, yeah, so this on top actually needs to be squared. There we go. we get 0.014 molar. So yeah, sorry about that. I forgot about squaring the H plus on top. So I just had to square the top line of that fraction there, and you get 0.014 molar. So 2 different ways, both give you the same answer. Pick whichever one you think is easiest and just go with that. But yeah, hope that has helped. Thanks, guys.